In this video, we will calculate the standard enthalpy of a reaction based upon using the standard enthalpies of formation that we can get from the back of the book. So our first equation is a combustion reaction where C2H4, which is ethylene, reacts with oxygen, 3 moles of oxygen to give you 2 moles of CO2 gas plus 2 moles of H2O. So the equation to solve this problem and get the delta H of the reaction, the enthalpy of the reaction at standard state, so the key word here, standard for standard state, is this equation right here. I rewrote the equation of the combustion. The enthalpy of the reaction at standard state is the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. Very important that you multiply by the stoichiometric coefficient. So let's first start with CO2 gas, which is the product, sum of the products minus sum of the reactants. So if we go to the back of the book or your internet source, we can have a table here which tells us the delta H enthalpy of formation at standard state. Standard state is 1 atmosphere and 25 degrees C of all these different types of chemicals. So let's first sum up these values for CO2 gas. So looking at this, I see CO2 gas to be minus 393.5, and that is our enthalpy of formation. So minus 393.5 for CO2 gas. Now that's for 1 mole, okay? But realize we don't have 1 mole. In the balanced chemical equation, we have 2 moles. So we got to multiply this number by 2. All right, plus H2O liquid. So states matter. Okay, we got to find the value for H2O liquid, not H2O gas or H2O solid. So looking at my notes here for H2O liquid, it's minus 285.8 standard enthalpy of formation. That's for 1 mole. Remember in our problem, this is why we got to always balance our equations. We got 2 moles, so we got to multiply that number by 2. So 2 times minus 285.8 kilojoules per mole. Okay, we got our sum of the products minus the sum of the reactants. So C2H4 gas. So C2H4 gas, looking at our table, is right here, C2H4. And C2H4 gas has an enthalpy of formation of 52.3, positive 52.3 enthalpy of formation. That's for 1 mole, and we do have 1 mole, so minus a 50.3 kilojoules per mole. Okay, I'm dealing with the reactant side. It's sum of the products minus sum of the reactants, plus 3 times oxygen gas. Oxygen gas is going to be 0 because that's a base element. It's the standard state, the most abundant state. But even if you don't know that, you can look this up on your table in the book or on the internet, and you'll find that O2 gas is indeed 0 for the enthalpy of formation, delta H. So it's going to be 3 times 0 kilojoules per mole. All right, so 2 times minus 393.5 is minus 787 kilojoules per mole. Plus 2 times minus 285.8 is going to be plus a minus 571.6 kilojoules per mole minus a 52.3 kilojoules per mole. And so let's do this in our calculator to get our final answer. Minus 787 plus a minus 571.6. Take that minus a 52.3. Doing that on my calculator, I'm getting an answer of... So the minus sign tells you this is an exothermic reaction, which means heat is evolved. Exothermic means heat or energy in the form of heat is evolved and liberated as a product in this reaction. So this is kind of common for all combustion reactions. Energy is not required to complete this reaction. Actually, energy is released during this reaction. This is all at standard state, 1 atmosphere, 25 degrees C, and the energy that is released alongside those products is minus 1410.9 kilojoules per mole.